Welcome all. I am Dr.Suresh, Assistant Professor, CSE Department, Sri Ishwar College of Engineering. I am going to take quantum convolutional neural networks for you. So quantum convolutional neural networks, it provides the bridge between the artificial intelligence and quantum physics. So quantum physics is the fundamental principles that describe the things about small as well as particles. So these small particles means it typically mentioned about atoms, atomic particles as well as subatomic particles. Then artificial intelligence. So it is about the science which deals about the information that is taken beyond the superficial nature, which means the artificial intelligence and quantum physics combined together to form the quantum convolutional neural networks. Particularly in this artificial intelligence, we are dealing about deep learning here. So, what is the need for studying this quantum convolutional neural networks? So, nowadays the artificial intelligence and quantum computing are the emerging technology. So, it is the cutting edge technology which provides a faster way of computations. So, normally in classical artificial intelligence, it is more powerful but computationally limited. The computational cost is somehow higher when compared to the modern methods. So, here the quantum systems provides mostly faster computations by using the concept of quantum physics. So, here we are using deep learning. In artificial intelligence, we are using deep learning along with the quantum physics. Okay. So, normally classical computers will be, that the working of classical computers will be depends on quantum, that is depends on binary bits, that is 0 and 1. But quantum computers, it depends on qubits. Okay. So, either 0 or 1 will be considered for normal computation, that is classical computers. But quantum computers, they use qubits, zeros and ones, and the combination of both. So, particularly this is used for handling the big data. Okay. So, normally artificial intelligence we used it to for handling the data like that is for learning, for reasoning, for learning, reasoning, and for natural language processing. Everything we are using artificial intelligence. But for doing it for in faster way, we are combining that with the quantum mechanics. So the quantum computing fundamentals, it uses qubit, that is the combination of both zeros and ones, and it works on the principle of superposition and entanglement. Okay. So superposition principle means here we are using zeros, ones, and the combination of both. Entanglement means, so the whole qubits will be exist there one after the other. That is, one output is fed back as input to the other. So the combination of or the chain of these bits will be providing the will be serving as the input and in turn the output. Okay. And the most important thing is here we are using the parallelism property of quantum physics. So parallelism property means many multiple operations at a time. Multiple operations. So the combination of that is the learning capability of convolutional neural network and the parallelism property of quantum mechanisms will yield the new emerging technology like called quantum convolutional neural network. Okay. So normally neural network is the phenomenon which inspire the property of human brain. Normally human brain is connected with nerve, that is neurons and various connections. So here the neural network is composed of neurons called nodes. Here we are calling neurons as nodes, and the connection is called weights. Okay. So by adjusting the weights, we can read the data. We can read the data by adjusting the weights. So this will help to reduce the error. Okay, balancing the weights will reduce the error. So convolutional neural network is particularly used for images, processing images as well as videos. Okay, it is normally used for extracting the features for images and videos. Here we are using convolution layer, pooling layer, fully connected layer, and activation layer and output layer. So convolution layer will detect the features from like edges, shapes and textures. Okay. Then activation layer will perform non-linear function for detecting the complex patterns. Then the pooling layer is used for reducing the size, or it provides the limit. It provides a way to reduce the patterns, and it helps to reduce overfitting problem. Then fully connected layer. Fully connected layer make the final classification. Okay, it will get all the extracted features and make it as data flattened and provide the classification output. Okay. So the overall hierarchy is from detecting low features to high features. So from convolutional neural network to quantum convolutional neural network, what it is done over there is it replaces the classical neurons with the quantum gates. As I said, it will replace the classical neurons with quantum gates as like convolutional neural network. Then the normal data with quantum states. Okay. So particularly the qubits, it will deal with the qubits. Okay. So overall architecture of this quantum convolutional neural network is as like convolutional neural network. Convolutional neural network is having the same input layer, here also input layer, and convolutional neural network is having convolution layer, here quantum convolution layer. Okay. Then there also convolutional neural network is also having pooling layer, there also pooling layer is there. So everything is just similar to the convolutional neural network, but the handling of input with qubits alone is different. So this is how the layer formation of quantum convolutional neural network. So it has various elements like unit operations, measurements, and feed forwarding networks. Then, so the input state is considered as yes, and the desired output is considered as y, and the mean square error is calculated by using this formula. Okay. So the this indicates the various input states, and this alpha provides the activation function. Then the various application of QCNN. So quantum phase recognition, then quantum error correction, then quantum chemistry and quantum control. For all quantum related things like quantum physics, quantum chemistry, everything we are using this quantum convolutional neural network. Here error correction is also possible, and for handling big data analytics we are using quantum convolutional neural